Okay, last podcast for the unit.
Hey, I have a problem here.
Well, the good thing is, this podcast has the solutions.
Oh, that's not what I meant, but let's figure out what that means. Okay, that's what I meant. Because we are looking at solutions. There's two different parts to the solutions that you need to be aware of. The solute and the solvent.
Okay, so the solute is the thing that's getting dissolved. It's the Kool-Aid that you put into the water, essentially.
Because Kool-Aid dissolves
Yes.
in water. It's a powder. And the solvent is the substance that does the dissolving. Usually, that is water
Yes.
in chemistry. But there are other things, there are other substances that can dissolve, other solutes. So if you look at these pictures here, you've just got beakers of water and then different things of sugar. Sugar will dissolve in water. So water is the solvent and sugar is the solute.
So that middle picture looks like it might be like sand or something, right?
Yeah, this beaker over here in the middle, it doesn't look like it dissolved. So there is no solute. It's just the sand sinks to the bottom because it's not soluble. It doesn't dissolve. And then there's another picture there of the Alka-Seltzer. Plop, flop, fizz, fizz. That's the commercial. Dissolving in water, solute and solvent.
Like dissolves like. What does that mean?
It means you can read the title to this slide.
Yes.
It means it's really talking about polarity. When you have substances that are polar, solutes, they will only dissolve in polar solvents.
So you're saying that anything that dissolves in water, which I think is polar,
Water
right?
is polar,
We learned that probably in the last lesson.
so anything that dissolves in water is also polar.
Oh.
If it does not dissolve in water, it is nonpolar because it'll only dissolve the like substances. So nonpolar things only dissolve in nonpolar solvents.
It's so simple.
So here we have a picture. What's that look like there? We've got water on the bottom, and there's a layer of oil on top.
So it looks like we got polar water down there and then non-polar oil. So they're not mixing.
You might say that oil and water don't mix.
Oh, I think you do say that.
I think you do say that. I think it's a very, very common phrase. So why do oil and water not mix? Well, one must be polar, one must be nonpolar, because they form two separate layers. Like dissolves like.
So water is known as the universal solvent because it actually dissolves a lot of things, and water is polar.
And remember, it only dissolves other polar things. And when we're talking about poles, we're only talking about the charges. So pretend there, look, if you look at this picture, you may want to draw a small sketch of it because the little green and gray atoms, you notice that they have charges on them. So let's pretend that that's a cube of salt, NaCl. There's positive Na and negative Cl. You have positive and negative charges. Those are poles, so they will dissolve in water. Now look at what's happening from the picture to the left to the right. The water molecules, they come and they just kind of take off atom by atom. They surround it and pull it apart.
And you can see that the negative ion, the anion, is surrounded by the hydrogen side of water, which is the partially positive side, and the cation, in this case, is surrounded by the oxygen side of water, which is the partially negative side of the water.
Let's take a closer look at that. And you're going to want to be able to draw and explain this. There's a kind of a zoomed in view of what you just saw, but only looking at two atoms. If you have a positive ion, like sodium, Na, water is polar, so the partially positive side, or the partially negative side of water, the oxygen, the negative will be attracted to the positive sodium. The oxygens are all oriented towards the atom.
Remember what Paula Abdul said, opposites attract, and it's true in chemistry.
I don't even know what song you're talking about.
What? The dancing cat?
Still moving
not
on very
YouTube
quickly.
dancing cats. But
Moving on very
animated.
quickly. If you look at the negative ion, the chlorine,
it's a classic.
you just won't let Paul Abdul go. Let's focus on the negative chlorine. It's the opposite. Water still surrounds it and pulls it off the rest of the atoms, but now the hydrogens are positive, or the hydrogens were always positive, but now the hydrogens are facing the middle.
Yeah, so the positive hydrogen is now attracted to the negative ion.
Positive, like Paul Abdul.
Right.
The positives and the negatives, opposites attract. The positive hydrogens will surround the negative ion and pull it apart. And that's how something dissolves. Literally, the water just comes in and surrounds atom by atom until you can't see it anymore. It's no longer in a cube. It's in a bunch of different smaller parts. Very good picture to be able to draw, hint, hint, and explain. There's a couple factors that affect solubility.
Surface area is one of them. So the more surface area a substance has, the more the solvent can actually reach the surface and pull the molecules apart.
So solubility is how much or how well it dissolves, right? So surface area,
The ability to be soluble.
What?
Yeah. Right.
If you have more of the surface exposed, more water will surround it and pull it apart. So that surface area makes sense.
Temperature, when you talk about temperature is really a measurement of how fast or how slow particles are moving. At high temperatures, particles move fast.
So if they're moving faster, they would hit the solute more often, and they would dissolve it faster.
Yeah.
So temperature would make it dissolve better. And then stirring is kind of the same principle as surface area. You stir it up, you kind of jostle it around. It comes in contact with more water, so the water has the ability to break it up faster when you stir it.
So, in summary, greater surface area means something can dissolve more easily. Greater temperature means it will dissolve more easily. And more stirring means it will dissolve more easily. So each of those things, when you increase each of those things on here, surface area, temperature, and stirring, the solubility has been increased.
So surface area, temperature, and stirring. Kind of, there's a Bob Marley song called Stir It Up.
Oh, yeah.
Yeah, it affects solubility.
Right.
It's much better than your Paula Abdul reference.